Steganography is a really fascinating subject. It's the act of hiding a file inside of a file, and you hide it in plain sight, but no one knows it's there, and no one can see it except people who are in the know. So we're hiding a file or just some data inside of another file. The data is hidden in plain sight, but you can't see it unless you know how to extract it. And it can be anything: text, an image, a media file, like a video or audio. It could be encrypted, it could not be encrypted, doesn't matter. The main file, the carrier file, the one that your average user will look at, there's nothing wrong with it. It's perfectly normal. You can look at it, you can read it, you can play it, whatever. But the hidden data is inside the file. So unlike alternate data streams, where the data it's an associated stream of data associated with a file sitting on an NTFS drive, this is actually embedded into the file. And when you look at it, you play the video, you listen to the music, you look at the file, you look at the web page, you look at the image, you read the text file, you don't see the hidden stuff. And the file is normal. Is this Trojanizing? Yes, it is, but with data that's not an executable. Actually, watermarking is an example of steganography, but that's not hidden. Okay, so the hidden data is going to travel with the file. And if you're going to retrieve the hidden data, you need to know which file actually has the data, and you need to know how to retrieve it. So, for example, Al-Qaeda is reported to have used steganography on their websites, and the commands are right there. The marching orders are right there. You'd have to know how to retrieve it to actually read what the secret messages are. The methods for steganography. There is a concept of using the least significant bit to hold data. We can do it with images, video, audio. With documents, we can use white space to hold data. Not that you see like extra carriage returns. We're not talking about that. We're just talking about the document is so big, but the data is only this much, and there's a lot of sort of unused space in terms of the size of the file. Or you can hide stuff in a folder using similar methods. Or we could just in ASCII text use white space. We could hide web objects behind other objects, web, and typically that would be like images, but it could also be code. We can hide stuff inside of spam or emails. Not that it's malicious attachments, that's not what I'm talking about. I'm talking about instead of like malicious JavaScript behind these things, it's secret messages. So it's not an executable. We could embed content in CDs and DVDs. There's something called natural text. It's a whole sort of a whole mechanism of converting something into something totally unrelated, like the script of a play, and then you go down a certain column the way they're laid out, and then there's the data. So it's hidden in plain sight. It's not encrypted. It's not scrambled. You just don't know the pattern to find it. We could hide a whole operating system inside of another operating system, the hidden OS. Have you ever found Easter eggs in a program? That's steganography right there. So like some programs, like once upon a time there was a version of Microsoft Excel that had a flight simulator game hidden in it. That was an Easter egg. That's a form of steganography. Or you could hide something in the source code of an application. So any way you can hide something inside something, it's in plain sight, but you need to know sort of how to find it. That's steganography. So look at these two pictures side by side. Can you see a difference? I can't. Just zoom in. I cannot see the difference looking at these two, and yet one is hiding information, the other is the original. If you don't have the original, good luck trying to find the variations. If you do have the original, which would not exist on an Al-Qaeda website, you certainly wouldn't have that, If you do have the original, you can compare for variations. Now, I want to actually show you how this works. Now, folks, I have brought up a blank PowerPoint. I just want to show you something called least significant bit. And so I'm just going to get rid of these text fields. I don't need them. And I'm just going to put in just a shape, something very simple here. And it has a default fill. Okay, fine. Now, I can just make it bigger, but it doesn't matter. This could be any image. I'm just picking one that's really simple. Let me right-click, and let me go to the fill. And I'm going to change this. Now watch this. I go to fill. I've right-clicked. I go to fill. And I'm going to change the color. So I can go to more fill colors. And notice how I could, Windows has a preview feature. As you go over different things, it changes the color. I'm going to go to more fill colors. Click here. And I'm going to choose something. Now, what I want you to pay attention to is this. And I don't think I can zoom in on this. I don't think it's going to help. No. Okay, sorry. You'll notice that right now this color falls here in the color spectrum. And colors are made up of combinations of red, green, and blue. At least what we call the not the colors that are reflective, but the colors that are I forget what it is, but basically light. So now watch what happens. If I change this around, watch how the numbers change. So like if I change it to this, and I accidentally closed it, and I go back to the more colors, you'll see how the colors have changed. Watch what happens when I change the red to 0. Notice that it will look very different. And if I apply it, of course, there's no red in it. So you have, in color, you have 3 different kinds of colors that are combined that make up something. Okay, so let me just go back to something that is, I don't know, something that, I don't know, let's pick something that, so we'll pick something here. In fact, what was our original? I have no idea what our original was. Let me just zoom up here. Okay, so I've got something. Now, taking a look at the 3 colors, do you notice that we've got the red, green, and blue? The range that you can go from is from 0 to 255. It's an 8-bit color scheme, from 0 to 255. You can't go any higher. If I try to go higher, can't go any higher. If I go to 0, of course, I can't go lower. There's no negative numbers. I'm trying to go lower. I can't do it. So just pick something in between 0 and 255. Okay. Now watch what happens. Let me just set this as an OK. And let me right-click this thing. And let me go one more time. Watch what happens when I slightly change these numbers. What we're doing is something called least significant bit. If we just change some of the low-end numbers slightly, you will, especially on a computer monitor, not see the difference. Watch what happens when I just dial this up by 1 to 129, or 129 there. Do you see a difference? No. I mean, look down here. This is the preview. No, you don't. Okay. Now let me just make a copy of this so you can see them side by side, all right? So these two are identical. I've got the original, I've got this. I'm going to change the least significant bits. Let me go to more fill colors. And I'm going to change this even to 131. 131. And I'm going to change the green to maybe 228. And the blue to maybe 237. And, whoops, not 27, 237. That's 27, that's way too much. I'm going to click OK, and I want you to try to see the difference. It is hard to see the difference, isn't it? And I have actually used a bunch of bits. I have modified the least significant bits. Well, what if I replace those least significant bits with data instead of just color information? Especially in an image that is complex with a lot of different stuff in it. I could be changing this green back here, and you wouldn't see it because your eye is focused on something else. That is the concept of least significant bit, and it is the primary way of changing or of doing steganography in image, audio, and video. We're changing least significant bits, and we're doing it on the assumption that your average person will never see the difference. There are any number of steganography tools. Here's just a short list. Steg Hide, Steggles, Steganography Master, SpyPix, PixelNut, Pocket Stego, DaVinci, Secret Tidings. I mean, there's a bunch. Here's just one example, Stego Hide, that is Linux-based. So there are so many here, and there are many beautiful GUI version ones as well, Windows version ones. Now, Steganalysis is the science of detecting steganography. There are challenges. Quite frankly, it is difficult. If you don't have the original to do a bit comparison, it's way more difficult because you don't know what you're looking for. You don't know what's not correct. The challenges are, first of all, accurately determining which file even has the data and what kind of information we're even looking for. And the data, even if we find it, it might be encrypted. So not only that, but if we suspect some files or data streams, in addition to the hidden stuff, they might have added random noise, just random characters or random whatever to throw us off. So this is what makes Steganalysis really challenging. Good Steganalysis, detecting steganography, requires that you have the original. But you could examine text files for unusual patterns, appended extra spaces and invisible characters. You could find image files that have just too many distortions in the image or the image quality was degraded. If you can compare the original with the Stego version, you could look at the color composition, the luminance, the pixel relationships, and find bit differences. You would scan the least significant bits for hidden data. Same thing with audio, same thing with video. And with video, you can actually have a combination of image and audio because video often embeds audio. There are steganography detection tools. Gargoyle, Steganography Studio, Steganalyzer, Virtual Steganographic Library, StegDetect, just a few of them. And what they'll do is they'll try to strip out things and look one at a time at different color elements or different something elements to look for anomalies. So that is the fascinating world of steganography.